This video we're going to talk about radian measure, but to better introduce that concept, let's talk about degrees first, something we're all more familiar with. Degrees, a full circle is considered 160 degrees, which makes a half circle 180 degrees. So if you draw a full circle here, let's say we start here at 0, if you go half of the way, you're going to end up at half of 180, half of 360, which is 180. Right, if I make a full complete circle, it's going to be 360. And for that, you can break it up. So if this is 0, that's 180. Halfway between that's be 90 degrees. Halfway between 180 and 360 be 270 degrees. We'll learn about these critical points here later. These are called gentle angles, and we'll learn about them more later. But in general, a full circle is 360 degrees. Right? In degree measurement, a full circle, one full rotation is 360. Then, if I ask you what is 1 degree? Well, 1 degree is just going to be 1 out of the 360 of these. So it'll be like a really, really small angle of 1 degree, right? Which is only 1 over 360 ifs of a circle. That's all it is. So that's all, like, you know what, we should all know what 1 degree is. It's a really, really small angle. How about in radian measure? So in radian measure, a full circle is not 360 degrees. We're going to call it 2 pi. So a full circle is going to be 2 pi, and we'll get more into that in a second why. And that makes half a circle, well, half of 2 pi, so just pi. Which would make these two, this point right here, well, half between 0 and pi, which is half a pi, or pi over 2. And then over here we have 1 pi and 2 pi, half of that would be 1.5 pi, also known as 3 pi over 2. And just like in degree mode, if you notice all our angles, anytime it's a positive angle, we go up this way. Negative angles, we go down. So our angles are generally going like this. Now, like how before, we talked about what a degree is. What is a radian? Well, a radian is by definition, you get a little history here if you want later, is just the length of the radius as an arc length. So like if I give you a circle here, let's say this radius right there is 2. When you go up 2 in the same direction as an arc length up here, that is 1 radian. So whatever the radius is, that distance up along the circle is a radian. So over here, right, we have an R, and we have an R right there. That gives us our 1 radian. So that's all a radian is. So it kind of depends. How big is it? Depends on the radius of the circle, but it's always proportional. The bigger the radius of the circle, the bigger the circumference. The smaller the circle, the smaller the circumference. But 1 radian would always have about the same measure, right? It's always about whatever the radius length is up the circumference. So that's radian measure. We start at 0, we go up to pi over 2, pi, 3 pi over 2, and 2 pi. So how do we go from radians to degrees? Is kind of the next idea. Well, if you notice when we did our angles here, when we talk about degrees, we start with 0 here, we went up, positive, 90, 180, 270, 360. In radians, the exact same measurement, but then in radians, so done with response to how long the angle is, how long the radius is, not to how big the angle is. Which is 0, pi, pi over 2, 3 pi over 2, and 2 pi. So how do we convert from one to the other? The key here is right there at pi. Right, we know when we talk about degrees and radians that pi radians is equivalent to 180 degrees. So we're going to use that as our jumping off point to convert from radian to degrees when we want to. And the form is pretty simple. Like it says right here, if you have degrees and you want radians, all you gotta do is multiply by pi over 180. Like that's our little conversion factor. Right, since we know pi and 180 are equivalent, we just convert. So if I have degrees, I want pi in my answer, multiply by pi over 180, you get your radians. If you're going the other way, if you have radians, which probably the way most people start off going, is like, okay, I have radians. What does that mean in degrees? Like everybody can't picture it. Well, if you have radians, it's its opposite. you're going to multiply by 180 over pi to get degrees. Now you notice right here there's a little note. When we do degrees, we always want to put a little degree sign at the very top. When you do radians, most books don't do this. I rarely see this, but I guess you put a C in the little top corner. Most people don't do that. We generally do radians. We know it's just a number. Leave it as a number. We know it's radians compared to degrees, which has a little degree sign. So let's go to our first example. Let's convert 45 degrees to radians. So again, I'm going from degrees to radians. Well, 45 degrees. I want radians, so I know I have to multiply by pi over 180. Pi on top. Because radians generally have pi, so that's how I know how to put the pi on top. This is a basic math problem. 45 over 1, I'm going to get 45 pi over 180. Once we multiply, we just drop the degree sign. Then you can reduce it. They both divide by 5, so 9 pi over 180 divided by 5. So it's 3, 15, 30, 36. And they both divide by 9. So pi over 4. So again, if you want to convert, if you want to convert 45 degrees to radians, you just multiply by pi over 180. We're just standing with decimals. Have 126.5 times. I want to make it to radians. So multiply by pi over 180. So in this case, I have decimals. I'm just gonna use my calculator. So I'll bring up a calculator, and I'm just gonna multiply this all in there. 126.5 times by pi, so second pi, right there, divided by 180. Divided by 180. Get our answer, 2.2074. We generally do 3 sig figs in IB, so 2.21. So it's approximately, this one was approximately signs, 2.21. So that's how you convert. So again, and then I notice it doesn't have a degree sign, so when I see that, oh no, it's a radian. It's not a small degree, it's a radian. And again, it's like, that's actually kind of big. It's probably like 2/3 of a top half of a circle. How about going the opposite way? Convert from degrees to radians. Convert from radians to degrees. So if we want to go from radians to degrees, I notice it has a pi in there, so I'm like, I want to get rid of it. So when you go from radians to degrees, pi should be in the bottom. So 5 pi over 6. Multiply that by 180 over pi to get my degrees. Again, so I already know when I see radians and I want to convert to degrees, you generally try to get rid of that pi, so the pi should be in the bottom. And that way they reduce. You can multiply across. 5 times 180 over 6. And this reduces, 6 and 180 reduce, that's 30. And I get 5 times 30 is 150. So 5 pi over 6 is about 150 degrees. I mean, it is 150 degrees. It's not about, it's exactly 150 degrees. And then we have one where we have decimal in radians. Just like last time, don't try to be a hero. If we're going from radians to degrees, it's all decimals, just use a calculator. 638. Again, I think about, okay, radians, like I get rid of the pi, even though there's not a pi here. So it's my mentality. So it's 180 over pi. So plug that into my calculator. There you are. So we're just going to do 0.638 times 180 over pi. And we get 36.55. So again, 36 is 36.6. About 36, approximately 36.6 degrees. And that's how we go from degrees to radians, radians to degrees. A lot of times at the start, people like to convert from degrees to radians. Sorry, from radians to degrees to get a better picture of what's going on. Hopefully this next little part will show you that you don't really need to do that. So let's talk about this drawing angles. I want you to be able to draw an angle and know where it's at. So let's first start with 200 degrees. Then we'll do some radians. So I'm gonna leave this charts out real quick. So when we want to draw angles, we always start the same way. You always want to start on the positive right side. That's our 0 angle. That's where we start every single time. If it's a positive angle, you move up. Negative angle, you move down. Another big part about this is that we're not trying to draw a perfect angle. It's just an idea. You just want to be in the right quadrant. That's the main goal here. Just get an idea what this angle looks like. So this is 0. That makes this 90, right, when we go up. So we 180, 270, 360. So 200 falls between 180 and 270. So it's in quadrant 3, and that's the only part that matters. So 200 degrees. Right, so we're going from here to here. That's our angle. Again, technically I probably should put it a little closer to 180, but the idea is just you want to get in the right quadrant. If you do that, you're good and golden. So how do we do the same thing with radians? So here's a trick I use for radians. So here's 0, here's pi. Let me erase. I don't need that anymore. That's really the 2 I care about. I guess 2 pi is also important. The trick to drawing radians is this guy right there. You want to think common denominator. So this is pi, and that's 3 pi over 4. So what we want to do here is rewrite this as 4 pi over 4, right? That's a 1 pi, so it's just 4 pi over 4. If you go over here, 2 pi, same thing as saying 8 pi over 4. This gives me better context of where I'm going. So I'm trying to get 3 pi over 4, here's 0. All the way over here will be 4 pi over 4, but I'm not there yet, I'm a little short, so you can be right there in quadrant 2. That'll be 3 pi over 4. So the angle that we go from here to there is 3 pi over 4. By the way, it's a few more. If I wanted 1 pi over 4, that'll be over here. 2 pi over 4 I might say, but 2 pi over 4 you can reduce to 1 over 2, that'll just be right there. 5 pi over 4 will be over here. 6 pi over 4 you can reduce, and then 7 pi over 4 will be right there. You just keep on going around. So I'm going to do a little faster with 11 pi over 6. So same idea, here's 0. Here's pi. Let me erase this if I don't need. It's in my way. So in this case, right, it's over 6. I'll make this 6 over 6. And if I went around again, it would be 2 pi, also known as, right, double this basically, 12 pi over 6. Now if I was doing this one, it would be 1 pi over 6. Going over here, 6 over 6, so low short would be 5 pi over 6. The low pass will be 7 pi over 6. How do I get down to 11 though? Well, 6 over 6 plus another 6 over 6 gets me 12. I haven't got that far yet. I'm a little short. So I'm going to be right there. That's 11 pi over 6 is in that quadrant. So it's in quadrant 3. And then number 4, pi over 3. Anytime it's only a 1 on top, it's going to be in quadrant 1 if it's positive. So here's 0. Here's pi. I'll put them all down. Pi over 2, 3 pi over 2. Right? The halfway point is pi over 2. Pi over 3 is actually smaller than it. I always think of it like pizza. Do you want half a pizza or a third of a pizza? Right? So this is the smaller version. So pi over 3 is anything that's a 1 on top is always going to be in quadrant 1. So that'll be my pi over 3. So the angle from here to here. Again, these are all just estimates of the angle. The main thing is you get the right quadrant. That's the idea.